We like to think history moves in a straight line. Every generation is a little smarter than the last. Technology always gets better, and everything ancient was simple. Then you look at what they actually built. A bronze computer more advanced than anything that would exist for the next 1,400 years. A weapon that burned on the surface of water and could not be put out. Sword blades with molecular structures inside them that we only discovered in a lab 30 years ago. These are not legends. These are physical objects sitting in museums right now, studied by scientists with CT scanners and electron microscopes. And in every single case, the conclusion is the same. We do not fully understand how they did it. These are 5 ancient technologies that should not exist. Number 5. The Antikythera mechanism. In 1901, Greek sponge divers exploring a Roman shipwreck off the island of Antikythera pulled up a corroded lump of bronze covered in barnacles, roughly the size of a shoebox. Nobody thought much of it. It got cataloged, put in a crate, and sat in a museum storage room for months. Then it cracked open while drying, and through the fracture, someone noticed gears. Dozens of tiny, precisely cut, interlocking bronze gears inside an object that had been sitting on the ocean floor since about 65 BC. What followed was over a century of scientists getting progressively more amazed. X-rays revealed the full internal structure. CT scans mapped every gear tooth in 3 dimensions. What came out was a device with at least 30 bronze gears that could predict solar and lunar eclipses, track the positions of all 5 planets visible to the naked eye, calculate the dates of the Olympic Games, and model the moon's irregular orbit. That last calculation requires math that our civilization would not formally develop for another 1,000 years. To really feel what that means, think about the timeline. After this device was built, humanity would not make anything mechanically comparable for 1,400 years. The next object of similar complexity shows up in 14th century Europe. If someone dug up a working laptop inside a Viking burial mound, the time gap would be about the same. And here is maybe the most unsettling part. It was found on a cargo ship, being transported as freight, which means this was not a one-of-a-kind miracle built by a lone genius. It was a product. Someone was casually shipping one across the Mediterranean. How many more were made? How many are sitting on the ocean floor right now? Number 4. Greek fire. In 672 AD, an Arab fleet sailed toward Constantinople to end the Byzantine Empire. They had been conquering everything in their path for decades. Their fleet was massive. The defenders were outnumbered. By every military calculation, the city should have fallen. Then the Byzantine ships moved out to meet them. And from bronze tubes mounted on the bows, they unleashed something the Arab sailors had never seen. Liquid fire projected across the water like a flamethrower. It did not go out when it hit the sea. It burned on top of the water. Sailors who jumped overboard were consumed by flames that followed them beneath the surface. Ships were engulfed in seconds. The fleet broke and ran. Constantinople survived. For nearly 800 years, Greek fire was the Byzantine Empire's most devastating weapon. Enemy fleets sometimes turned back, just on the rumor that Greek fire ships were in the water ahead. The formula was the most closely guarded secret in Byzantine history. Only a tiny circle of people knew it at any given time. When Constantinople finally fell in 1453, the secret died with the city. Modern chemists have been trying to crack it ever since. The best theories involve petroleum, pine resin, sulfur, quicklime, and saltpeter in various combinations. But no mixture produced in a modern lab has matched all the properties described in historical accounts at the same time. A liquid that can be shot through bronze tubes. That ignites on contact with seawater. That sticks to wood and skin and cannot be smothered or washed away. Several of those properties actually contradict each other from a basic chemistry standpoint, which is exactly why nobody has been able to recreate it. The Byzantines did not lose Greek fire by accident. They made sure it could not survive them. And they succeeded so completely that one of the most effective weapons in the history of naval warfare exists today only as descriptions written by the people it was used against. Number 3. Damascus steel. Between the 9th and 17th centuries, swordsmiths in the Middle East were producing blades that European metalworkers could not understand, could not copy, and could not stop getting killed by. Damascus steel was not just sharper. The edge was finer, the flexibility was greater, and the surface had these flowing water-like patterns that looked almost alive under the right light. Not decoration. That was the visible signature of something happening inside the metal that nobody else in the world could replicate. In 2006, a team of German researchers put a fragment of genuine Damascus steel under an electron microscope. And what they found changed the conversation. The metal contained carbon nanotubes, molecular structures of pure carbon, arranged at the atomic level in formations that are among the strongest materials known to science. Materials that humanity formally discovered in 1991. Materials we are currently researching for use in aerospace engineering and advanced medicine. Medieval blacksmiths were forging them into sword blades 800 years earlier. The process appears to have been unintentional. A happy accident created by the specific ores they were using, combined with particular forging temperatures that caused carbon to organize itself at the molecular level during cooling. When those ore deposits ran out or trade routes shifted in the mid-1700s, the technique vanished along with the supply chain that had accidentally made it possible. We build particle accelerators, we sequence genomes, we land precision instruments on other planets, and we cannot make a sword as good as the one an anonymous blacksmith made in a Syrian workshop 900 years ago. Number 2. Roman concrete. The Pantheon in Rome was finished in 125 AD. Its dome is the largest unreinforced concrete dome in the world. It has survived nearly 2,000 years of earthquakes, floods, the fall of an empire, 2 world wars, and millions of tourists walking through it. It is standing right now. Meanwhile, concrete highways built in the 20th century start falling apart within 50 years. Scientists have known the basic Roman recipe for a long time: volcanic ash, seawater, lime. But why Roman concrete actually got stronger over the centuries while modern concrete steadily gets weaker was a genuine mystery for generations. In 2023, researchers at MIT figured it out. Roman concrete has tiny white mineral chunks scattered through it called limeclasts. For years, scientists assumed these were mixing mistakes, sloppy craftsmanship. They were not mistakes. They were the whole point. When water gets into a crack in Roman concrete, it contacts these limeclasts. The lime dissolves and recrystallizes inside the crack, filling the damage from the inside out. Roman concrete does not just resist cracking. When it cracks, it fixes itself. And here's the kicker. Seawater, the thing that slowly destroys modern concrete, actually makes Roman concrete stronger over time. Roman harbor structures built 2,000 years ago are in better shape than concrete piers built 50 years ago. Engineers are now trying to reverse engineer this for modern construction. So far, it has not worked at scale. The specific volcanic ash has properties tied to a particular region of Italy that cannot be easily substituted. The Pantheon is still standing, quietly outlasting everything built to replace it. Number 1. Pumapunku. At 12,800 feet in the Bolivian Andes, in a landscape that is cold, remote, and barely able to sustain farming, somebody built something that makes modern engineers go very quiet. Pumapunku is a temple complex made from andesite and diorite, 2 of the hardest stones on Earth. Harder than iron, stones that require diamond-tipped tools to cut with any precision in a modern workshop. The blocks at Pumapunku were not roughly chipped into shape. They were precision cut, surfaces flat to fractions of a millimeter, drill holes of perfectly uniform diameter at consistent depths, interlocking H-shaped pieces that snap together like manufactured parts. No mortar, no glue, just the geometry of the stone itself holding everything in place. Some of these blocks weigh 130 tons. The nearest quarry is 10 miles away, across terrain that rises and falls by hundreds of meters. The people who built this had no iron tools, no steel, no wheeled vehicles that have ever been found, no written language anyone has been able to identify. Modern engineers have said publicly that replicating the surface precision of these blocks with contemporary equipment would be challenging. Explaining how it was done without power tools, without metal harder than bronze, at high altitude, with stones this heavy, has not been satisfactorily accomplished. Everything else on this list, we at least understand the principles. The gears, the chemistry, the metallurgy, the concrete. We understand what was done, even when we cannot fully replicate it. At Pumapunku, we are still arguing about what tools were used. History does move forward, that is true. But what these 5 objects tell us is that it also forgets. Entire technologies were developed, perfected, used for centuries, and then lost so completely that the best labs in the world spend decades trying to understand what some anonymous craftsman already knew by hand. What else was built? What else was lost?